Hello everyone, thank you for joining Renewable Powered Future 2021 Huawei FusionSolar Smart PV and Large-Scale Energy Storage Global Virtual Summit. This event is moderated by PV Magazine. My name is Eckhard Guras. I'm the publisher of PV Magazine. Huawei, an industry-leading smart PV solution provider, has launched many great products to the market and has been proven to be successful by leading the global inverter shipment chart for 6 years. At this year's SNEC exhibition in Shanghai in June, Huawei first introduced its revolutionary solution for the utility scale market and also unveiled its very comprehensive energy storage solution. We are very excited to have this opportunity to discuss with industry leaders and stakeholders on the topic of energy storage, and also for the first time at this global event to learn more from Huawei on their energy storage solution. Before the event starts, please allow me to invite Dr. Fang Liangzhou, Chief Marketing Officer of Huawei Digital Power, to give us a warm welcome speech to share his thoughts on how to achieve the renewable powered future. Welcome.
Ladies and gentlemen, welcome to the 2021 Huawei FusionSolar Smart PV and Large-Scale Energy Storage Global Virtual Summit. I am Fang Liangzhou, CMO at Huawei Digital Power Technology Company. Please allow me to thank you on behalf of our company for your support and trust. Huawei Digital Power was established as a company this year. Our vision focuses on the leading power digitalization for the zero-carbon smart society. We hope that this new platform can help accelerate carbon neutrality through intelligence technologies for the renewable energy industry. We believe that the key to building a future-oriented power system based on the renewable energy is the integration of the digital and power electronics technologies. This new power system will include the following 4 high features: higher proportion of renewable energy, higher proportion of the power electronics equipment, higher degree of the digitalization, and higher intelligence. Of this, higher proportion of the renewable energy has become a global consensus. While traditional PV power generation typically results in volatile power grids, energy storage represents the key to overcoming this instability and accelerating the development of the PV power generation. The PV industry and business mode are evolving with the rapid development of PV plus energy storage, which will speed up the construction of new energy systems. Huawei Digital Power has accumulated more than 10 years of experience in energy storage R&D and has already shipped 5 gigawatt-hour lithium battery geared towards various scenarios. Traditional energy storage systems now face multiple challenges. Low battery capacity resulted from the connection mismatch, high operation and maintenance cost, and safety risk due to inconsistent and uncertain battery characteristics. To address these concerns, Huawei has integrated digital technologies and power electronic technologies in PV and energy storage systems. The smart string modular design refines the energy storage system management at the battery pack level. Pack level optimization improves the charge and discharge capacity by 6%, while rack level optimization offers a further 7% improvement. Meanwhile, the innovative distributed heat dissipation architecture extends battery lifespans, and intelligent technologies such as AI and cloud BMS are used to evolve system safety from reactive to proactive. This solution achieves higher yields, optimal investment, smart O&M, and safety and reliability. The fourth industrial revolution features powerful new technologies such as 5G, cloud computing, and AI, which combine to impact every aspect of society. We strongly believe that integration of the digital technologies will unleash the full potential of energy storage, driving the industry towards its carbon neutrality goals. As such, we are delighted to work with so many talented partners and friends. We have invited the leading experts and opinion leaders to join us at this summit so that we can discuss and share the latest technologies, experience, and insights relating to utility energy storage for PV system. As of December 31st, 2020, Huawei Digital Power has served 1/3 of the world's population across more than 170 countries and regions, generated 325 billion kWh of green power, saved 10 billion kWh of electricity, and reduced global carbon emission by 160 million tons, equivalent to planting 220 million trees. We hope you enjoy the summit. Together we can build a zero-carbon smart society and realize carbon neutrality in the very near future.
To get started, I would like to introduce the agenda of today's event very quickly. In the coming hour or so, we will first be speaking to Mr. Chen Guoguang, President of Huawei Smart PV. We will then hear from Sam Wilkinson from IHS Markit on global market opportunities for large-scale battery energy storage. Jorge de Miguel from Vector Renewables will then speak on potential application to improve revenues in existing PV plants. Felipe Hernandez from FRVX and Engineering will follow with a discussion on next steps for large-scale energy storage. And finally, Hariram Subramanian from Huawei will introduce the Huawei Smart PV and String Storage Solution. We welcome you to interact with us on the discussion panel on the right side of your screen should you have any comments. The Huawei team will try their best to get back to you. To kick off today's event, we would like to welcome Mr. Chen Guoguang, President of Huawei Smart PV. We are happy to speak to you via Huawei Idea Hub, and we would be grateful if you could set the scene and talk about the importance of energy storage and Huawei's vision in this field. So the first question is, let us first take a step back to the original FusionSolar solution in 2013. Since then, solar PV has evolved rapidly, bringing forth in the utility scale segment improved single and dual axis tracking technology, bifacial high-powered modules, and now competitive battery storage. How does Huawei's latest FusionSolar all-scenario PV and storage solution handle this complexity to deliver lower LCOE and LCOS?
This year, we have launched FusionSolar all-scenario PV and storage solution, which succeed to the advantages of smart string design, such as intelligence, modularity, multi-MPPT, high protection, and so on, and comprehensively reinvent the power electronic architecture and create the world's first Gemini plus-minus 1,500 watt design. This architecture design can help to support larger sub-arrays, higher voltages, higher power module, tracking systems, thus could reduce LCOE by 7% and even enhance the grid, redefine the PV plant standard, and can also adapt to large-scale wind plus solar plus storage project as well. It integrates our smart string energy storage solution and is compatible with AC and DC coupling, and uses intelligent PV plus storage collaboratively control algorithm to realize synchronized characteristics to improve grid stability. With smart PV generator, it allows PV to be from only current sources to become a stable voltage source. It further integrated AI technology and couples with modules, tracker, and grid, provides the end-to-end system to cover multi-scenarios such as PV or PV plus storage or microgrid and pure storage to create a comprehensive and intelligent all-scenario PV plus storage solution. It has three major differences compared with traditional solutions. First, the volt-force bipolar string. The use of smart PV controller and smart string controller dual controllers through the plus-minus 1500 watt design on the DC side to achieve the 3000 watt architecture. While achieving higher voltage, it can also meet all existing standard requirements related to electric and safety regulations for PV power plant. Achieving a larger subarray up to 8.8 MW, support for larger current component, and higher ratio up to 1.8 DC to AC, higher power generation, and lower capex will further reduce LCOE by 7%. At the same time, from passively following the grid to actively enhancing the grid, traditionally fewer generators to smart PV generator, and finally realize that PV to become the main energy source. Secondly, coexistence of PV and storage. The PV and storage coordinated control algorithm turns the PV system from an uncontrollable and unstorable current source into a stable voltage source, creating the PV generator. The new Huawei Smart String Energy Storage System, distributed energy storage architecture, fully modular design, park-level optimization, rack-level optimization, and other innovative technologies will ultimately achieve a LCOS reduction of more than 20%. Thirdly, full intelligence. A wide variety of advanced ICT technologies such as AI and cloud are catalyzed and organically integrated with PV modules, trackers, cables, array controller, energy storage, grid, and inverters are fully coordinated and fully coupled, including the latest intelligent IV 4.0 diagnostic technology, DC M-Bus, intelligent PID protection, SDA's algorithm, intelligent grid connecting algorithm, etc. Fully release the potential of each string, create a zero inspection O&M experience, stronger grid support capabilities, so that power plants have three-dimensional awareness and create an open and efficient, intelligent PV and storage system.
Energy storage has been a key topic in the PV industry, and a lot of companies are entering into this arena. What does Huawei bring to the table when it comes to energy storage?
We think energy storage is an important foundation and key technology for building a new energy system with renewables as the main sources. In order to transition to a green and low-carbon energy system and achieving the goal of carbon neutrality and ensuring energy safety. In the field of energy storage, Huawei has accumulated more than 10 years of R&D experience and the application of more than 5 GWh lithium batteries. This time, Huawei is bringing a full scenario smart string energy storage solution. In the traditional energy storage solution, multiple modules are connected in series into a rack, and multiple racks are connected in parallel. Thousands of, or even 10,000s of modules are coupled with each other. If one module fails, it will affect the others. Our solution is through the battery pack level and rack level optimization. The solution can achieve more refined management with an accuracy of no more than a dozen batteries, which is hundreds of times higher than the traditional solution. Besides, the refined management can achieve precise measurement of each pack with optimized depth of charge, which improve the available power of the system. On the other hand, this innovative design can support the mixed use of new and old batteries and the phased charging mode, saving customer initial investment. Meanwhile, it is equipped with full modular design, including PCS, air conditioning, and so on, greatly improve system availability and simplifies operation and maintenance. The modular air conditioner realizes a distributed temperature control layout, and temperature equalization effect is greatly improved than the traditional solution. The temperature difference is reduced by more than 10 degrees, and the battery life is then greatly improved. Huawei attached great importance to the safety of energy storage system. Through the pack level and rack level optimization and management design, the system can achieve accurate management of battery packs, which can accurately isolate faulty modules and improve system safety. At the same time, as a leader in advanced technology in the ICT industry, through intelligent and digital technologies such as cloud, BMS, and big data, faulty batteries can be accurately identified with red flags to fire hazard, and system level and actively safety can then be ensured. Huawei Smart String Energy Storage Solution increases the discharge capacity, reduces O&M costs, ensures safety and reliability, and achieves a 20% reduction in LCOS, helping to build a new energy system with renewables as the main source.
What do you think about the future energy trend? Based on its very impressive ICT track record, Huawei has been a leader in advancing digitalization in the power sector. We have also heard the big news that Huawei's digital power business is now independent. Could you please elaborate what this means for your PV customers? And what can we expect from Huawei digital power business in the future?
Well, we believe that there are three major trends in the future. First, we are progressing towards the fourth industrial revolution and accelerate our entry into the intelligent world. Second, carbon neutrality accelerates the energy transition. In the future, the world will build a clean, low-carbon, safe, and efficient energy system. Third, renewable energy will become definitely the main energy source. The integration of energy and information flow has become inevitable. In the future, new energy systems will move towards high perception, two-way interaction, intelligent, and efficient, plus comprehensive digital and intelligent technology. Huawei has more than 30 years of deep understanding in the field of digital technology and energy technology. The development direction of Huawei's digital energy is to reduce emission, accelerate energy transformation, and realize a zero-carbon and smart society through technological innovation. For Huawei Digital Power, it would be one cloud plus 4 main application scenarios plus 5 root technologies plus N. N means an open ecosystem. It integrates basic technology innovations such as electronic, thermal, energy storage technology, cloud and AI technology, and ICT technologies. We use bit manages watt. By leading the digitalization of energy, we will build a zero-carbon intelligent society. For our solar customers, we are aiming to build a full ecosystem, end-to-end energy solution, not only in energy generation, but also in energy storage and consumption. Further lowering the LCOE and enables PV grid parity to PV plus storage grid parity through the integration of energy and information flow, an open energy cloud system, and an open technology ecosystem to boost renewable energy become the main energy source. Success is secured when people put their heads together. We hope to continue to innovate and create greater value for our customers to make technology benefit all.
Thank you, Mr. Chen, for setting the scene. And to give us an overview of where the global energy storage market is heading, it is my pleasure to hand over to Sam Wilkinson, Director, Clean Energy Technology at IHS Markit.
Thank you, Mr. Eckert. It's also my pleasure to have this conversation with you.
Thank you, Mr. Chen. We will then hear from Sam Wilkinson from IHS Markit on global market opportunities for large-scale battery energy storage.
Hi everyone, my name is Sam Wilkinson and I'm a Director in the Clean Energy Technology Group at IHS Markit. I'm delighted to be with you here today to talk about global market opportunities for large-scale battery energy storage. Now let's start at the very beginning. There is huge pressure on the global economy to decarbonize, and that pressure has only grown throughout the global pandemic that we've seen for the last year or so. And the chart here on the left shows where all of the energy sector greenhouse gas emissions came from in 2019. What you can see is that power generation makes up the largest share, accounting for over a third of global emissions. And the way that we tackle this sector is becoming very clear. We switch to low carbon generation, principally wind and solar. And as we move to higher levels of intermittent renewables like that, we have to add more flexibility into the system, and that means increasingly turning to batteries and energy storage. But that's just one of the places that greenhouse gas emissions come from in the energy industry. Buildings, transport and industry still make up around about 2/3 of greenhouse gas emissions, and we have to decarbonize that as well. And there's really two main ways that can be done. Either we electrify, which means that we turn increasingly to the low carbon generation that we've already talked about, increasingly using batteries as well. And of course, batteries are being used in the transport sector widely for the electric vehicles that are becoming increasingly common. And the other way that we can decarbonize these sectors is to move to low carbon gas. And that tends to mean hydrogen. And actually, the green production of hydrogen using electrolysis from renewables may also mean that we need more batteries in the future as well. So there's lots of reasons why batteries are becoming such a hot topic. Falling cost and increasing contribution of renewables, meaning that we need a more flexible grid to accommodate all of that. We have batteries falling in cost and huge improvements in technology that are making them the technology to beat for providing flexibility within the grid. We see a growing value placed on reliability and energy independence. And that is also another reason why batteries are becoming such an important technology. And of course, overarching all of this, as I mentioned before, is this increasing urgency to decarbonize the global economy and industry around the world. So let's have a look at the energy storage industry. We've been tracking this industry for a long time, and it has grown each year, with the exception of 2019, when the industry actually declined for the first time. 2020 was an exceptional year when the market was very, very resilient to a global pandemic, which provided many, many challenges across the board. But 2021 really marks the start of a very strong period of growth for the industry. We predict this year that the industry will more than double. We'll see over 10 gigawatts installed for the first time, equating to 28 gigawatt hours of energy storage capacity. And this growth is not just coming from major established markets, but it's coming from a lot of smaller emerging opportunities as well. So this is our outlook for the battery energy storage market out to 2030, showing annual installations as they grow each year out into the future. What you can see is that the residential market is growing steadily. We see people increasingly installing batteries alongside rooftop solar to help maximize their solar self-consumption and reduce their dependency on the grid. We also see the C&I sector growing steadily, with businesses using energy storage to optimize their energy usage and reduce their energy bills. But the real growth driver going forward is the large-scale front-of-the-meter installations, and that is really what is driving the bulk of growth going forward. And one of the things that has really helped this growth, one of the things that has really enabled it, is falling costs of batteries. Battery costs have fallen, for lithium-ion specifically, in the region of 80% since 2012. This is a huge improvement in cost, and it is what has really enabled the industry to take off in the way that it has. It is also crucially enabled by the uptake of electric vehicles. The investment in scale and in technology and in manufacturing for batteries has really been what has enabled lithium-ion costs to fall so significantly. The other thing that you can clearly see from this graph is there is two key technologies playing a role here, both different types of lithium-ion battery with different properties. LFP slightly lower in cost than the potentially superior NMC technology, which has a higher energy density. But that energy density hasn't proved so important in the stationary grid energy storage space, as it is much more valued in the automotive space. And what we see is that as battery costs fall, batteries can do a wider range of different things in the grid. So what we're showing here is some of the different applications, some of the different things that batteries can do, and we're breaking that down into the different durations of batteries that are required. So on the left-hand side, behind the meter, batteries are beginning to do things that they have never really existed before: optimizing solar self-consumption, home energy management, optimizing energy bills, avoiding peaks in energy usage to reduce peak demand charges, for example. This behind the meter sector has grown rapidly, as we mentioned previously, but it hasn't grown as quickly as the front of the meter sector. What we see here is that, to start with, short duration applications, so frequency regulation typically, have been the real starting point for any market. It's the first place that we really see batteries starting to contribute to the grid. And of course, a short duration battery is less expensive. But as the cost of batteries has fallen, we've seen longer duration batteries be able to play a role. So we increasingly now see 4-hour batteries doing things like capacity or renewable firming. And these things have become possible as costs have fallen. Where we see a more open book and more potential for different technologies to play a role is in the even longer duration segment. Further in the future, when renewables are making up an even higher proportion of the power system, it's likely that we'll need weekly or even seasonal or even longer storage to deal with the large surplus of power that will be generated at certain times, but will actually be needed later on in the day, in the week, in the month, or in the year. So what does this look like in terms of actual data? Now, this chart shows in some key battery energy storage markets how the front of the meter market for the next 3 years will break down in terms of primary application. And there's a few things that jump out here. First of all, the range, the diversity that you see. Every country slightly different, with different applications playing very different roles. We see frequency regulation, we see capacity markets opening up. We even see wholesale arbitrage becoming an important driver for the market as well. But the standout thing is that nearly in every single country, the biggest contribution comes from renewable enhancement. And that is largely the combination of large-scale solar with batteries to provide a more dispatchable, more flexible solar system, which can provide increasing value in the overall power mix. And solar plus storage is also helped along by policy. We've seen costs fall such that the combination of solar and storage is increasingly competitive with other forms of generation, but policy plays an important role as well. And you can see how the market is really taking off in the next 3 years, in 2021, 2022 and 2023 here on this chart. A large part of this is due to the US market, where the solar investment tax credit, or the ITC as it's commonly known, is starting to really drive a huge pipeline of solar plus battery installations, and that is a large part of that global forecast going forward. However, we've seen multiple gigawatt hours of solar plus storage tenders awarded in the last 9 months or so. We've seen that in Israel, we've seen it in Portugal, we've seen it in Germany, we've seen it in Chile, and we will likely see it in Spain in the near future, and there are many other places where we expect to see the power markets turning to solar plus storage to provide clean electricity in a very stable, dispatchable, and flexible way. I also wanted to touch on today, before I finish, some of the key technology trends that we're seeing at the moment. We see an increasing focus and the increasing importance of intelligent energy management systems. We see people increasingly realizing that the value of energy storage comes from very intelligent and sophisticated optimization, allowing the battery to really capitalize on the different revenue streams that may be available to it and how they may change throughout the day, throughout the different hours, and it's crucial that the battery can really tap into those to maximize its revenues. We also see an increasing focus on maximizing performance and really concentrating on the overall lifetime costs of a system, rather than just purely focusing on the lowest possible upfront cost. That can mean looking into things like augmentation strategies and O&M strategies, and really understanding how the benefit of these different approaches can reward with a longer lifetime or a lower overall cost across the lifetime. One of the other trends that we see is increasing use of DC coupled batteries alongside solar. This helps to drive down the hardware costs and also potentially increases efficiency with less conversion steps. And this is something that is becoming more and more common as large-scale solar and storage is rolled out around the world. And that concludes my presentation today. So just a few key messages for you to take with you. First of all, battery energy storage and other clean energy technologies are absolutely key to decarbonising the global economy. We see that they will be increasingly turned to as we move forward with this global mission. 2021 will be a record year for the battery energy storage space. We predict that the market will more than double, and for the first time we'll see over 10 gigawatts of battery energy storage installed globally. Falling costs, which is crucially enabled by the scale that we're seeing, which comes from the batteries that are used in the electric vehicle space. And these falling costs are crucial to enabling batteries to do a wider range of different things in the power system. And finally, we really see the pairing of solar plus storage becoming increasingly common as costs become more and more competitive, and as more and more markets around the world turn to this combination to really help to decarbonize their power systems. So thank you very much for listening to my presentation today, and thank you very much for Huawei for having me here.
Thank you, Sam. It is very interesting to see that front-of-the-meter installations will be driving growth in the market over the next decade with a 160% growth rate. Jorge de Miguel from Vector Renewables will focus on this market in the next presentation.
Dear viewers, my name is Jorge de Miguel, and I am the Technical Director at Vector Renewables. First of all, I would like to thank Huawei for organizing this event. With this session named Hybrid Solutions for Energy Storage and Case Study, I will be introducing our vision on commercial large-scale applications of batteries. It will be interesting to see how the use of storage can depend on different parameters, and also to explore the many applications that large-scale storage can offer. From all the different energy storage technologies, we're going to refer always to battery storage, and not to other technologies such as pumped hydro, compressed air, or others. And I will be using the acronym BESS, or BESS, which stands for Battery Energy Storage System. This presentation will be divided into 4 sections. First, I will briefly describe Vector Renewables, the organization that I belong to. Secondly, I will introduce the microgrid simulator, the software that has been used to run the case study. Then I will explain the different services that battery energy storage systems can provide. And finally, I will present an actual case study that employs storage for energy shifting purposes in a solar PV plus storage hybrid facility. In order to provide a bit of background, let me quickly explain who Vector Renewables is and the type of activities that we have been performing regarding energy storage. With over 15 years of experience in the renewable energy industry and a global presence of 10 offices around the world, Vector Renewables is a leading service provider that covers the complete life cycle of projects through its 4 business lines. As asset managers, we are currently managing the operation of 3.7 gigawatts. As technical advisors, we have conducted engineering and consulting services on over 90 gigawatts of projects. As M&A and financial advisors, we have helped structure and close transactions and financings of over 5 gigawatts, and we have an internal team of lawyers providing specialized legal advisory. Regarding the topic at hand, we have a storage technical advisory division in order to support our clients in all the challenges that they can face in energy storage projects. I will not go into the details because of time constraints, just suffice to say that we have advised through the complete life cycle of the project, and we do this for both hybrid, standalone, and off-grid based solutions. In order to perform an analysis on hybrid systems, including those with storage, it's very convenient to make use of simulation softwares. We have actually developed an in-house software called the microgrid simulator for these purposes. This tool allows one to run multi-scenario and multi-year analysis on industrial plants, renewable assets, plus storage, in order to identify technical and economic performances and find optimal scenarios and optimal solutions. The microgrid simulator allows one to design complex systems composed of different elements and technologies combined to form a microgrid. Now we're going to focus on hybrid solutions, and we're going to explore the main uses of BESS when combined with other generation facilities. The examples presented will all be in relation to solar PV plus storage, but the same application would apply for other technologies, such as a hybrid wind plus storage system. Today, the expected applications of large-scale electromechanical batteries are mainly 5. And the technology that is typically used for these solutions is that of lithium-ion, due to its higher penetration in the storage market and to its lower cost per kilowatt hour. Now, the first application is something that I'm certain most of you have heard about, which is energy shifting. Energy shifting consists on controlling the power output of the generation facility so that its output fits with a certain reference target value as instructed by an external command from the operator of the grid, or according to an optimized profile defined by the operator of the plant. The surplus energy, the surplus power, is stored and discharged afterwards in order to rebalance power when energy is below the target power, or in times when capture price is higher and hence the revenues of the plant can be increased. The usual C-rate batteries to support these services are lower than 1 C-rate. The second important application is that of ramp rate control. In this application, the combined use of batteries is effective in helping reduce the dynamics of output power during plant startups and shutdowns, and in other moments that present instabilities like passing clouds. The idea is to keep the variation of the output power values as low as possible and without oscillation, in line with a certain slope of megawatt hour per minute that cannot be exceeded. In case of energy oscillations above that reference slope, that is, when the output increases at a faster rate than the slope, the energy oscillations are stored in the battery. In case of oscillations due to defects in the energy, lack of energy, that is, when the output decreases at a faster rate than the target slope, the oscillation is corrected by discharging energy from the batteries. You can see how this would play out on the 2 sample graphs presented on the slide. How the BESS allows for the system to have much smoother outputs. The idea is to keep a more stable output power and a more stable energy profile. Potential applications in PV are during the sunrise and sunset of the plant, as well as during variations due to passing clouds. And the usual C rate of batteries to support these services are around 2 C rates, with a typical ramp rate control slope of 1% of power plant nominal power per minute. This application is currently required in several parts of the world, such as specific areas of Japan and Puerto Rico. Our impression is that this service is going to be widely implemented by grid operators, as it allows the control of the instabilities in the grid due to the intermittent nature of the renewable energy. The third important application is peak saving. Peak saving consists on, as the name implies, cutting the peak power of the plant during peaks in energy generation, when energy generation can even surpass electricity demand. In order to make the most use of the electricity produced by the plant and to not lose this energy, the BESS allows to store the energy in batteries in order for it to be exported to the grid at a later moment in time, normally at peak demand hours when the capture price is higher. Peak saving presents benefits for all main participants in the electrical market. From the perspective of the owner of the facility, the energy export can be delayed to hours when the electricity cost is higher, thus maximizing revenues. Utilities also benefit as they can reduce their cost in readapting the generation profile on their peaking units. The grid operator can rebalance the operation without the support of peaking units. And finally, electricity users can benefit from buying electricity at prices that tend to flatten over time. Now, typical C rates are between 0.5 and 0.25 in order to allow for applications from 2 to 4 hours. The fourth important application is grid support, what is commonly known as ancillary services to the grid. We can find different types of ancillary services, such as voltage support, frequency control, and reactive power control in combination with inverters. Batteries with highest C rates, 4C and higher, are required for these services where a prompt power support is needed. This is done by charging or discharging the BESS in a short period of time, usually below 15 minutes. For vector renewables, this is probably the most important application. Batteries can become a major player in providing ancillary services support to the grid as the percentage of penetration of renewable energy increases worldwide. And it can also become a key revenue factor for the hybrid plant owner. This application is most fitting to BESS due to the very own nature of the widely used electromechanical technology that is limited to a certain number of charge and recharge cycles, as well as its time limitation. In the world, Australia already makes wide use of BESS and hybrid systems for ancillary services purposes. However, many countries still lack a developed regulation that makes it possible to develop these services from a regulatory or economic standpoint. Finally, we have the Black Start application. An additional benefit of energy storage systems is their ability to provide Black Start services. Black Start is the process of restoring a generator or a part of an electric grid to operation without relying on the external electric power transmission network to recover from total or partial shutdown. Traditionally, small diesel or gas generators have been used to start larger generators, which in turn are used to start the main power generators of the grid. The environmental benefits is quite clear when we can replace these CO2 emitting facilities with a zero emission generator. But now that we have explained the main uses for BESS, let's move on to the last part of this presentation, where we want to introduce a case study that we have run. We present on a theoretical exercise, the potential use of a combination of a PV plant plus a battery management system, and the way to find its optimum size for a given rated output power. This slide details all the different parameters pertaining to the hybrid system that we will simulate. These are just some of the parameters that can be considered and configured in the microgrid simulator. We have a project which is located in southern Italy, set to start operation in 2021 and to operate for 30 years. We consider a discount rate of 7% and an inflation rate of 1.25%. The PV plant is a 50 megawatt plant with a specific production of 1,450 and an annual degradation rate of 0.5%, capex of 620,000 euro per megawatt, and an annual OPEX of 25,000 euros per megawatt. For the BESS system, we have considered 9 different scenarios or cases, ranging from the 10 megawatt hour case all the way to the 20 megawatt, 80 megawatt hour case. We will be comparing the results from all of these cases. The other parameters for the BESS systems are presented in the slide. We will also consider that the BESS can participate in both the spot market, the MGP, as well as the auxiliary tertiary market, described as third. To complicate things a bit more, the capex for the BESS system has been made dependent on the installed capacity, according to these graphs. One for the power component, ranging from 132 to 140,000 euro per megawatt, and the other for the energy component, ranging from 145 to 170,000 euro per megawatt hour. The following slide shows the main results for scenario 1, which is the 10 megawatt hour BESS installation coupled with the 50 megawatt PV plant. We can see the yearly gross margin of the full system. This gross margin is divided between the energy market in red and the ancillary service market in blue. We can see that for the hybrid system, most of the revenue comes from the spot market. Then we can see that the energy production of the PV plant decreases over time with the degradation. And on the last graph, we see that the margin is specific for the BESS system, where we can see that the main component of the revenue is in fact the ancillary service market. The next slide shows the usage of the BESS over time, where we can see that over the 30 years of life, the system undertakes about 35,000 cycles, and it is replaced or refilled 4 times as the system reaches 60% residual state of charge, which is one of the input parameters to the system. Next, we will see an example of 1 week of operation. In particular, the first week of June 2022, The first graph shows the electricity prices for the spot market, as well as the prices for ancillary services under the tertiary market, and how these prices evolve along this week. The next slide shows the state of charge of the BESS for that same week, with the detail of when it imports or exports energy from and to the spot market, or when it participates in the ancillary services market by bidding up or down. Finally, we can see the combination of the PV plant output and the BESS and how they interact with the spot market. If we combine all the graphs together, we can see how the system is simulated in a way so that total revenues of the plant are maximized. We can see similar results for scenario 9, which is the 20 megawatt, 80 megawatt hour system. The additional storage capacity results in a higher amount of peak saving and energy shifting. The BESS system is charging from the PV plant or from low electricity prices and exporting at moments of high prices. In the case of the 9 scenarios presented in these case studies, and considering the original system assumptions, the main sensitivity results can be seen in the following heat maps, where we can analyze the overall IRR, the net present value, the levelized cost of electricity, or LCOE, as well as other KPIs. In this specific case, the bigger BESS installation results in higher LCOE, but also higher IRR. Now, as final conclusion, it's important to note that results can vary greatly depending on input parameters and market conditions where the projects are to be located. Participating only on the energy market is not yet profitable in most cases unless other incentives or subsidies exist, or unless other uses such as run rate control or provision of ancillary services are considered. As penetration of renewable increases, providing the services described in this presentation will increasingly become a requirement. Currently, even though they have decreased in the past years, BESS prices are still high and might be too expensive for most applications. It is recommended, however, that permitting and planning of new projects allows the future installation of BESS systems once prices have decreased further. It's important also to be able to efficiently simulate a multitude of scenarios in a short period of time in order to choose the best solutions for a given project at a given location. With this, I would like to end my presentation, and thank you all so very much for your time and attention. You can find my contact details, and I'm available for anything you may need. Thank you.
Thank you, Jorge. You provided an excellent overview of how large-scale battery energy storage can improve the business case for a PV power plant. I would now like to welcome our next speaker, Felipe Hernandez, Managing Director of FRVX and Engineering.
Hello, everyone, and welcome to this presentation about the utility storage business. Today, what I will try to do is explain the journey we are doing on this world to transform the company from a pure renewable energy generator and a small renewable IPP to a energy service company. So first of all is explain who is FRV. FRV is a company that is generating renewable energy, but has been in the market for a long time and always thinking what is required and what will come in the future. Our objective has been make an affordable green energy and put it in the market, and on this path we have been always looking for the next frontier, how we should evolve. So we have been, the company has been there for almost 15 years, and on this time we have been able to put in operation more than 2 gigawatts of projects, and we have a pipeline of 3 gigawatts. We have a strong presence in different markets in 5 continents, and we have invested more than 5 billions of US dollars on these years. So we know how to move to new areas, to new markets, to new business, and how to deliver projects. And if you see here our footprint, you can see how we are in some key markets for the new storage business, like our UK, Australia, and Chile. So we are in a position where we have the spirit, we know how to do the things, and we are on the right places on the right time. So we are ready to start the journey to transform or to create these new business models. And just what we need is the platform to do it. When we move to the storage, we are moving to a new business model that requires new skills, new capacity, and new strategies. So we think that do the things in the same way that has been done before could be so risky. So that's the reason that we decide to create a new platform, a new business unit inside FRB, which the aim to lead this transformation, identify this new business model, and bring the company to the new horizons. And it's come from analysis of the market. If you see what is happening now in the solar sector, you can see that it's a mature market that is very good because it's boosting the evolution to net zero carbon grids, but the projects are becoming so competitive, and you can see what's happening in Portugal or in other places. But at the same time, there are a new area, new market, mostly unexplored, where a huge capacity to generate revenues is still there. And for example, it's public, it has Neoen, is making a big part of their revenues from their storage project in South Australia. So we have the options to keep competing in a red ocean, very competitive one, or move to a blue ocean with a lot of new opportunities, but also risks and uncertainties. So this blue ocean is based in what the grid and the grid operator, that is one of our main stakeholders, need. And what they need is new flexibility service, regulation service, that in this transition, the other main operators of the market, the other generators, are not able to provide. We can see what's happening in UK this winter, with several low reserve capacity warnings has arisen, or what's happening just a few weeks ago in South Australia, when there were not enough demand to regulate the grid due to the high distributed generation. So this situation, these pains of the grid operator are leading to create new markets, like the DC market in UK, focus or designed for batteries, where virtual inertia service are required, and also the contingencies FCAS in Australia, just to manage all the unexpected events that could affect the grid stability. And here you can see how a real asset owned by FRB in UK is generating revenues. Each color represents a different revenue market, different revenue stack, and it's very curious, it's very symptomatic, see how we are changing week by week, day by day, the weight of each market. And it is because you need to do a follow of the situation almost hour by hour to decide what is the best market in each moment to deliver your service. And by this combination, this active managing, you are able to secure a higher revenue stack. But to do that, the key is have, for sure, a good system that allows this flexibility, but a very good also software that is able to identify these trends and bring your service to the different areas. There are not too much companies involved on this area because it's very advanced technology. So it's other of the keys of the storage. A partner, a good company that allows you to manage the battery in the best way. But the possibilities will not end in this day by day manage. If you can see what's happening in Spain this winter, for example, you can see how some days we face very low energy prices, and just a couple of days ago, the prices reached up to 70, 80 euros per megawatt hour. So there are a huge opportunity if you are able to move the energy from one day to other one in the same week or in a different week, a different month. And it's very significant also what's happening with the wind projects in South Australia. You can see in the graph how some projects in different months had a net revenues that was negative. So in the one month they have to pay to generate energy, while in other months they reach average prices very high of 80, 90 Aussie dollars per megawatt hour. So a system with the capacity to move the energy from these bad months to the good ones will generate a lot of revenues and will secure the viability of the new projects. Also, it is linked with the problem of the grid curtailment that will be more and more common in a high renewable penetration system. So the installation of storage together the renewable will allow to reduce these congestions and the curtailment that are suffering the projects. So now the question is, should we move to standalone projects or hybrid projects? The standalone projects will be a service concept where you are going to provide the service required with the grid to maintain the stability. So you will need to define very flexible assets with capacity to balance from one service to other and evolve in the future to meet the unknown necessities that will have the system. On the other hand, the hybrid should not be a PV plus storage project. It should be a full integrated project with a value that is above the PV or a battery one. And the way to do it is through the proper integration in a low level of the system by the use of DC coupling inverters that will generate some kind of generation block dispatchable at this level, and this capacity with the use of an advanced software will create a system capable to manage the energy in an efficient way. So the view is that most of the PV projects will become hybrid projects in the future, but at the same time there will be a huge space for the standalone one. And will be a next step. If we think in the electric vehicle objective in Spain, we find that we have an objective to have 5 million of cars by 2030. It will mean that we could have on these cars a storage capacity like 300 gigawatts hour. And most of the time, this capacity will be available because the car is used just 5–10% of the time. So a system, a grid that is capable to take this free capacity and be used to provide service will be a major change in the industry. And we come back again to software and systems. So finally, the takeaways that we have learned from this journey is that we are in a new business that will require new skills and a new approach. This new approach will allow you to face a blue ocean where a lot of unexplored revenue sources are there to be catch, but of course, a lot of risk will be in the way. The value is in the software, not in the hardware. So we should focus in deploy advanced systems that are able to meet our capacities. And the batteries, as we know today, that is used to manage the day by day, will be just a part of the business. We will have also all the seasonal storing and, of course, the vehicle to grid business. And finally, the DC coupling will be a major change and enable technology to evolve in the hybrid projects. So thank you so much to share your time with me, and happy to answer any question you could have. Thanks.
Thank you, Felipe. You highlight the UK and Australia, but it looks like we will soon be seeing many other markets embracing both standalone BESS and hybrid PV and storage solutions.
Renewable energy is becoming the main energy source and playing an increasingly important role of helping establish a new power system. Energy storage will be a critical component in this system to track the uncontrollability, inconsistence, and uncertainty of traditional renewable energy systems.
Hello everyone, I'm Liu Xuan. Today, we are bringing you here to our first energy storage pilot project in Jinan, Shandong Province. Please follow me. I will show you the whole project and explain our leading digital and power electronic technologies. The objective of this project for the user with regards to energy storage is to help adjust the peak valley power consumption, which means the energy is charged at night and is discharged during peak period and peak hours during the day to supply power for the campaigns. The average power of the campaigns is about 30 kilowatt and the peak power is 50 kilowatt. It is expected to guarantee for about 10 hours of power supply from the storage per day. Moving forward with me, let's have a quick look at the equipment applied in this project. Lunan 2000 2.0 MWh 2H0 Smart Street ESS, Smart ECU 2000D, Lunan 2000 200 KTL H0 PCS and DC box, auxiliary transformer, and main transformer. In this ESS, here is a door-mounted air conditioner and 6 of it are installed in one container. Here are the battery packs. 16 320 Ah cells in each battery pack with internal battery pack optimizer. The 21 battery packs are connected in series and the rack, and 6 battery racks are connected in parallel. This top right corner is equipped with smart rack controller, and each battery rack connects to one DC and DC module. Right down here is DC box and fire extinguishing system. We will show you how those technologies are applied in the system and achieve unique values for the project later.
In the traditional energy storage system, one central PCS manages more than 2,000 battery cells. As these cells are parallel and serial connected, the internal differences will cause several mismatch. Centralized cooling system worsens the mismatch due to the uneven working temperature, leading to reduced usable capacity, quick battery degradation, higher O&M costs, and lower safety.
In Huawei Smart Street ESS, we use innovative technologies such as pack and rack level optimization, distributed cooling, and module PCS to achieve higher discharge capacity. The optimizers in parallel with battery packs ensure that every pack can be fully discharged and charged. When a battery pack reaches the full charge or discharge state, the optimizer in the pack starts to bypass the battery pack, so that other battery packs can continue charging and discharging, and every pack can be fully utilized regardless of cell differences. Our intelligent rack level management allows the racks to run independently, eliminating the mismatch between parallel racks, maximizing the potential of each battery rack, and increasing the discharge capacity throughout the life cycle by 15%. What are the other technologies that we have brought more energy for this project? Moving here are the distributed air conditioners, which could individually cool each rack, and together with mixed air tuner inside the pack, so that the temperature differences in a container less than 3 degrees Celsius. Thus, the battery lifetime could be extended by 50%. Safety and reliability are always the first to be considered for the large-scale storage energy system. Considering of this, we have developed 4-level safety assurance design to ensure the safe operation of the plant.
Firstly is a smart internal short circuit diagnosis, based on AI analysis of circling curve buses. Smart internal short circuit diagnosis could identify hidden short circuit tendencies and predict fire hazard.
Secondly is a battery pack self-protection. The battery pack optimizer isolates the battery pack and could turn off the switch immediately. Thirdly, the battery rack could shut down the system actively to prevent fault spread. And these 2 circuit breakers and fuses could isolate 2-level faults to make sure multiple intelligent protections. The last one is system-level protection. As you could see here, when the internal gas is emitted due to the overheating or damage of the battery pack, the smoke sensor inside the container starts to exhaust the gas to the outside based on the concentration of the dangerous gas to reduce the concentration. Besides, this equipment also could release inside gas to reduce the concentration inside to prevent fire and explosion.
The simple O&M is another value we have added. With pack level optimization, every pack is automatically calibrated. No need of system shutdown. And when fault occurs, plug-and-play design keeps the system free from expensive on-site diagnosis with experts. Thus, this simple O&M could reduce around 2 million RMB cost per year for a 200 MWh project, and no annual equalized charging maintenance is required.
It nearly comes to the end of today's Sunlight Tour. Thanks so much for your time, and we all wish to see you in person to discuss more of this project in the very near future. We strongly believe that the integration of digital technologies will unleash the potential of energy storage and drive the industry towards carbon neutrality goals. Thanks again and goodbye.
Our next speaker is Hariram Subramanian, who will provide an overview of Huawei Smart PV and String Storage Solution release.
So welcome to my presentation. My name is Hariram Subramanian. So I'm in charge of utility scale PV power plant solutions by Huawei Technologies. I will walk you through today on the Huawei Smart String PV storage solution for utility scale scenarios. As you might know, let's say in the PV business, many power plants were built in the early days with 1100 old technologies. So round about in 2013 to 2015, we were actually providing our solutions on this kind of voltage with 1100 volts for power plant solutions. And then round about 2015, we moved into 1500 volt solutions for utility scale power plant projects. We would now take this 1500 volts, which is actually in the DC side, the low voltage directives. We would try to build on this to maximize the utilization of the DC low voltage directives by going into a bipolar architecture, which would be the plus minus 1500 volt solution, which is our FusionSolar 8.0 Gemini solution. So there were key takeaways that we brought in with our 1100 volt solution. That's a Huawei string inverter technology with dual stage conversion with a lot of MPP trackers or the boosters in the DC side. We brought in the concept with fuse free, and then we moved into, let's say, newer innovations like IV curve diagnostics that came with our next generation solution. We were able to do also algorithms to control the tracker with our next generation solution, and with this Gemini solution, we're going to bring in much advanced technological innovations. For example, we can build with the Gemini solution voltage source concept or a grid forming concept, and we are able to provide solutions that will interact with the grid in a more friendly way with this solution. There's quite a lot of interesting things, so please be with us to understand what are the new concepts that we will bring in, and also we will showcase you today on, let's say, the storage technologies that goes into the solutions with the Gemini, as well as a solution that will take into a DC coupled or as an AC coupled solution. So from the technical specifications on the PV products, what we are actually bringing into the market very soon is basically three things. So one is the smart string controller, which is the Venus 2032U0, and then is the smart PV controller Sun 2000 345 KTL HO, and then the smart string ESS, which is the Luna 2000 utility scale storage solution. So the smart string controller is basically a DC-DC converter. So it just does the DC-DC conversion and then provides as an output a plus minus DC that actually is taking as the DC transmission of power till the inverter, which is actually clustered very close near to the system, or let's say near to the transformer station. And this inverter is the smart PV controller with 315 kilowatts rated power and 345 kilowatts as the maximum output power. So it's all both IP66, and the smart PV controller will have, let's say, communication with Ethernet or with RS485 to do all the grid support and to get commands from the grid and to do regulations. There will be a monitoring bus which actually works as a power line communication between the DC-DC converter and to the inverters. And the smart string ESS would basically have around about 2 megawatt hour storage with 1C and 0.5C batteries, and would be around 20 feet container with less than 30 tons in total weight. And it will also come with Ethernet. In the communication interface would be IP55, and would come with quite a lot of interesting concepts like short circuit detection and also integrated fire protection units in the system. So this is the overall key products that will actually come into the architecture. We will see a little bit more on how the architecture would look like. So this innovative 1500 volt plus minus bipolar architecture, when we would compare it with the FusionSolar 6.0 to this Gemini architecture, there is two important things here. So one thing is that in the Gemini architecture, for example, the DC-DC converter is carved away and is taken out of the PV inverters, and the DC-DC converter is kept very close near to the panels or to the tables. Whereas in the FusionSolar 6.0, you have the inverter kept very close near to the panels or the tables, and then there is an AC transmission happening till the transformer station. With the FusionSolar 8.0 Gemini solution, you have a bipolar DC transmission till the inverter, and from there the inverter will convert from DC to AC and step up to the grid with the transformer station. So that is a very key difference here, and this will enable to reduce the BOS cost significantly, because the amount of metal used, for example like cables, aluminiums, would go down significantly, and we could also bring in a large power plant block design with this Gemini solution. As Gemini means twins, so there is actually, let's say, a twin concept here that goes into the power plant solution as well. And system yield harvest is increased significantly to around about 2%, and also the redundancy and modularity is maintained with the new solution, which comes as one of our legacy concept here. So that will also reduce the OPEX significantly. And what is important is also the grid supporting features. We are able to run the system in a very weak grid situation with a short circuit ratio around about 1.2, and we are also able to bring the solution to work in microgrid situation, islanding situation, and enable the grid forming feature concept with the FusionSolar 8.0 solution. So in total, let's look into what are all the key takeaways here. So the key takeaway is that already existing innovations that we will bring will go into the next level. That means the smart IV curve diagnostic feature will take here as well. We will have the anti-PID solution with the Gemini architecture as well. We are able to provide the tracker coupling solution, the smart STS, which we are already having in our existing status quo products and solutions. And in addition, we have also the grid coupling concept here integrated. So in total, you have actually a DC-DC converter, bipolar DC transmission, and the DC to AC inverters, and then you have actually the smart transformer station, and then you have the monitoring platform and the portal to the system and to the grid. We will now take a look on actually the complete PV smart generation unit. Yeah, the PV smart generation unit is composed of, let's say, the smart DC-DC converters, the storage containers, which integrates also smart DC-DC converters, and the smart PV generation inverters. What is the key difference here when we are looking into, let's say, technologies classically is having rotational machines, which are actually synchronous generators, and when we talk about status quo, which are actually the PV inverters, which are just grid tied inverters feeding current into the grid. And the most important thing is the next generation technology that we would bring in, which will do, let's say, grid forming concept. So we can make most as a voltage source solution here, that will also work in situations, for example, to do frequency balancing and to provide frequency regulation when it is needed in the grid. And we can also bring in voltage stability support and do power oscillation dampings with the new solution. Let's understand a little bit more on the energy storage challenges. What are the typical challenges? The most important thing is the safety behind the system. The thermal runaway problem is seen in various places in some power plants. That has created actually quite a lot of fire in the power plants, and we want to first address the safety part in the system. And also the other important thing is the low amount of system utilization and operating lifetime, as well as the large amount of O&M that is required in the power plant with an existing or with a solution that is actually available in the market. So we want to differentiate a little bit and also bring in the new technologies here. Those new technologies are, for example, that will avoid fire, and also bring in high amounts of reliability and lifetime with the storage solution, and also reduce the O&M significantly. The first important thing is the use of lithium iron phosphate solutions. So the lithium iron phosphate is actually thermally very stable. We have done and performed variety of tests, and the test results on the lab side and also in the field side indicate to us that the lithium iron phosphate solution is the most robust and stable in terms of the thermal stability that is used in our battery container solutions. And if you would compare this with a classical NCM based solution, there's also cobalt involved in it, and also we want to avoid the use of cobalt into the solutions, and we have deployed quite a lot of solutions with lithium iron phosphate, not just in the PV but also in our data center UPS, where we are also having the solution with our data center storage solutions there. Other important thing is when we would compare how the system would look between the centralized solution and actually with the smart solution. The centralized solution does not have a rack level, pack level optimization, or let's say balancing. So it is all done at one centralized mechanism way, which is actually bringing in quite a lot of mismatches in the solution. Comparing it with the smart string ESS, we bring pack level optimization, rack level optimization, include the modularity behind that, thereby bringing in proper state of charge calculation and also bringing in the lifetime improvements into the storage solution that will be deployed in the utility scale here. So in total, we are talking about the LCOS. The Smart String Energy Storage Solution speaks about the optimum LCOS, the levelized cost of storage. When we would take a case of 100 megawatt, 200 megawatt hour storage, we are seeing here an LCOS decrease of around about 15%, basically coming from the lower capex, more energy, simplified O&M operation, and also the safety and reliability that comes into the solution here. One important thing is everything comes pre-manufactured, prefabricated, so there is no need to be, let's say, to do balancing on site. So everything is done automatically by the electronics. Very quick commissioning could be done in 5 days. Rack level module cooling system, firefighting units are all integrated here. And this prefabrication brings in a very quick deployment and very easy grid connection in very few amount of, let's say, days as soon as you get the battery cabinet and so on. Pack level optimization is one important thing. We want to go a little bit more detail on this topic on what exactly is done here in the pack level optimization. In the pack level optimization, when we would also compare it with the central solution to the smart string ESS solution, the most important thing is the elimination of mismatch between the packs. This is very important because the mismatch would have significant consequence that will impact the lifetime as well as impact the state of charge calculation. And would finally bring in, let's say, improper charging and discharging time, and so the battery is not utilized effectively. So it's very important to have a pack level optimization, which we have deployed into our solution here. And so there is no centralized management here, but actually a kind of a distributed management. And this also brings in high availability, safetiness, and very easy maintenance in the system. And the next level is the rack level optimization. So here, for example, in the rack level, there is a rack level optimizer or a smart battery rack controller, which when we would compare it with a traditional centralized solution, this is done more granular, and this brings in also high amounts of optimization that will increase the lifetime and also provide a proper charging and discharging capacity with the battery concepts here. So when we would compare it here, the most challenging thing is actually with the centralized solution, the state of charge, because there is actually different racks and there isn't a possibility to match all the racks, and that brings in a difference in the rack quite significantly high, and which will bring in a discharge issues with the centralized solution, and this is all optimized with our solution in the smart string ESS concept. Everything goes modular, so that means there is no quick wear and tear parts here. Modularity brings in high amounts of availability of 99.9% here, and so this brings in also a concept, if you can look and see it, like if there is an inverter which is centralized, if there is actually a failure, the entire system is actually failed. But in terms of modular concept, in case of a failure, of potential failure in the smart string inverter, so only that part of inverter is failed, the availability is still kept or maintained high because the system is actually functioning without a problem. So this is one important difference when we would compare it with the centralized concept, because with our battery solution, we are bringing in the modularity here. Simplified O&M, this is very important when we speak about an O&M time of around about 25 years. So it's very important to also look into the methods and measures that goes here, because typically in a centralized concept, one needs to have some trained personnel to do battery balancing and also to do some kind of optimization, and that is quite time consuming, requires quite a lot of personnel on site. When we would compare it with the smart string energy storage solution, so the routine O&M, if it's just a very simple concept done, because maintenance is done automatically with the O&M concept with the state of charge calibration, which is not needed. So that's what we call it as the smart O&M here. And also there is less amount of people needed on site, and it is just as a plug-and-play solution, and which will reduce the number of O&M personnel on site, and also battery replacement is done quite easily within some 2 hours time period. Safety and reliability is very important. We have incorporated some algorithms inside the system which will look into if there are any potential thermal runaways and provide warnings and alerts. And we have the smart internal short circuit warning mechanism inside, which will reduce the risk of fire by more than 90% and compared to a traditional solution there. So this is very important to avoid potential thermal runaways and to ensure security and safety inside the power plant. Safety and reliability is taken as one important priority in the design into our battery concepts. When we would compare it with FusionSolar 8.0 DC coupled solution, and with the traditional solution here, with the DC coupled solution, we have, let's say, as I said, the DC-DC converter, the battery container, and the inverter DC to AC with the transformer station. There are 3 important value proposition here. One is significant reduction in the capex. The second one is the higher yield and harvest. And the third one is the charging efficiency. Significant improvement in the charging efficiency will all contribute to the LCOS reduction and brings in a very high amount of, let's say, performance into the power plant with the solution. So looking into the key value proposition as a big picture holistically, with the smart PV, we see a reduction of LCOE of around about 7%. Coming through capex savings, typically in the cables and in the installation cost, O&M efficiency increasing around about 50%, the yield increase of 2%. And when we would look into the smart string ESS as a big picture holistically, with an LCOS reduction of 15%, coming through improvements in efficiency increase of 1.5%, capex savings of 30%, and energy increase of 13% in the entire power plant with the smart string ESS solution. So everything packs into, let's say, the solution that goes into the utility scale scenario with our Gemini architecture together with the DC coupled storage. We would see that this concept will go and bring in much amounts of grid stability and friendliness. And we would also see some grid forming features and concept like virtual synchronous machines with our next generation solutions. So thank you very much for listening, and we'll be more than happy to answer any questions that you might have. Please keep in touch and get in contact with us for any questions. Thank you very much.
Thank you, Hariram, for this great overview. What are the main takeaways that you would like to summarize for everyone? Maybe the top unique values and technologies that Huawei brings to energy storage for PV and renewable energy applications.
The key takeaways, if you would look in, we have to understand what is the status quo right now. Right now we are speaking about technologies where we have the inverter connected or tied to the grid, where the grid is actually creating the anchoring of the voltage. With the storage concept together with our inverter solution, we are able to bring in a very interesting concept called as grid forming. So it's a grid forming technology. That means we are able to build this kind of grid voltage or make the system act as an voltage source. The advantages here are tremendous, as we are talking about 100% of renewable penetration in the future. So we need this concept right now. And we would be able to then bring in techniques where we could have capability as a black start to operate in a microgrid situation, in an islanding situation, as well as try to work in a grid tied situation. So it brings in a lot of flexibility to have large scale power electronic penetration into the grid, to bring in ancillary services, inertias, and so on. The other important aspect here is related to the safety. So the storage actually is a very safe system if you look into the building blocks and the technology and the material science that goes into the products. And also coupled with a high amount of modularity and brings in system reliability, which a lot of our customers are looking for here. So the key takeaways are an opportunity to bring in a stable grid in the future with grid forming concept, modularity that will bring in high amounts of, let's say, availability to the power plant, because we are talking about a resilient and robust power plant in the future.
Thank you. What do you see as the barrier for a wide adoption of energy storage on PV plants? How does Huawei try to solve this issue?
Yeah, I will speak from the technical perspective. As of now, there's quite a lot of challenges, but we are addressing these challenges through technology. The first important thing is a complete system integration, which comes from, let's say, a company who understands power electronics and also battery technology, and who are able to bring in the complete integration of the system, which our customer wants. Because as of now, things are done from the so-called system partner, or let's say system companies who integrate different technologies but don't look into the entire system holistically. And at the same time, there are quite a lot of challenges in the technical side on techniques like battery balancing, understanding this algorithm behind the state of charge, safetiness, because a lot of our customers are worried about the safety of the power plant because you have chemistry in the power plant with batteries. So these are the topics that we have addressed technically through our hardware, software, and also the algorithms that goes into the product, and that brings in end effect very high amounts of safety, reliability, and for our customers availability to the power plants. So these are the most important things that were like barriers from the technical side, but we have addressed through our technology and innovations to bring in this kind of concept to our customers.
Thank you very much, Hariram.
Thank you very much, Eka, for your questions.
We have come to the end of the event, and it has been a great pleasure to moderate this event. We would like to thank again all of our presenters and partners for your contribution. A big thank you also to all of you who have joined us today and who helped make this event engaging and insightful. The recording of this event will be shared online. Please stay safe, take care, and see you again.